Hi there, and welcome to another Papetti Math YouTube video tutorial where I'm going to be teaching you, yes you, Algebra 1. And in this video, we're going to be continuing on with equivalent exponential expressions. And we're going to be looking at exercise number 4, where it says in these next examples, you may be required to convert one or more expressions so they result in having the same base. So we look at exercise 4, part A, and we see our bases are 49 and 343. And 49 to the second power is much larger than 343, so we're going to have to change both of these bases in order to arrive at the same base. And 49 we should recognize. We should recognize that 49 is 7 squared. So I'm going to rewrite 49 as 7 to the second power, which means 343 must be 7 to a power as well. So using a guess and check method, 7 times 7 is 49. 49 times 7, oh, there we go. That's 343. So 7 to the third power is going to be 343. Now I have a whole bunch of multiplication going on in here. I'm going to have some multiplication here. I'll try to clean this up the best I can. Right now, I'm just going to simplify that piece right there into the first step. So what I'm actually going to do is do it right there by erasing it. I'm going to distribute 3 to the x minus 1. So it's going to give me 3x. 3 times negative 1 is negative 3. This will make it a little bit simpler when I do my next step. 7 to the 2x, distributing the 2, multiplying, plus 4 is equal to 7 to the 9x minus 9. Now I have the same base, which means my exponents must be the same. So I'm going to set the exponents only equal to each other and get 2x plus 4 is equal to 9x minus 9. So when I subtract all of my x's to one side of the equation, I'll get negative 7x plus 4 is equal to negative 9. I'm going to subtract my 4 over here, and I'm going to get negative 7x running out of room is equal to negative 13. I'll divide both sides by negative 7. And yeah, this is a funky looking solution here, but that is in fact the correct solution. X is equal to 13 over 7. Would have been very tough to solve for 13 over 7 in any other way than this method here. So x is equal to 13 over 7, and when you substitute 13 over 7 in for x, you will get two equivalent values. So now we have 100 to the 3x plus 2 in part B is equal to 10,000 to the negative 2x plus 8. And this one, you actually could either change both bases to make them base 10, or you could just change this one base, which is what I'm going to do, because I know that 100 squared is 10,000. So I'm just going to change that 10,000 to 100 squared, because they are the same thing. Bring down the 100 to the 3x plus 2. I'm going to simplify this by distributing over here to each term outside. So I have 100 to the 3x plus 2 is equal to 100 to the negative 4x plus 16. Now I could set my exponents equal to each other, now that I know my bases are exactly the same. And what I'm going to get here is 3x plus 2 is equal to negative 4x plus 16. I'm going to move all of my x's to one side of the equation, and I'm going to get 3x plus 4x is 7x plus 2 is equal to 16. Let's subtract 2 from both sides, why not? And get 7x is equal to 14, and finally divide both sides by 7, and I will get x is equal to 2. Good so far? Good, because now we're going on to part C. Part C, we have 8 to the x power is equal to 128 to the x plus 4 power. And here we're going to have to change both bases, because if you try to just change 128 to 8 to a certain power, 8 to the second power is 64, 8 to the third power is 512. So you can't get 128 by doing 8 to a power. So we're going to have to change 8. And what do we know about 8? Well, oh, how about 2? 2 times 2 is 4, times 2 is 8, which means 2 to the third is 8. Bring down the x. So that means 128 must be 2 to a power also. What power must that be? Well, I'll count on my fingers. 2 times 2 is 4, times 2 is 8, 16, 32, 64, 128. That's 7. So 2 to the 7th power is going to give us 128. So now I can simplify this by distributing, and I'll get 2 to the 3x is equal to 2 to the 7x plus 28. And now, since my bases are exactly the same, I could set my exponents equal to one another. So I'll have 3x is equal to 7x plus 28. I'll solve this by subtracting 7x to get all of my variables on one side. And I'll have negative 4x is equal to 28. And when I divide by negative 4 to isolate x, I'll get x is equal to negative 7, which is the value that makes these two expressions up top equivalent. All right. Moving on to part D. Part D might look a little bit different, but that's because it is a little bit different. And we're going to get into those in parts D, E, and F. So when we see a fraction, 1 over something, that should give us a hint of what kind of exponent this is going to be. And the kind of exponent that's going to be is a negative exponent. So I'm going to make that into a regular old number, not a fraction, by bringing it back to the numerator and making that 16 to the negative x is equal to 4 to the x minus 6. Now that I have bases in non-fraction form, I can now change this 16 to 4 to the second power, because 4 to the second is the same as 16. Bring down my negative x, bring down everything else that I have. I'm going to distribute over here, and I'll have 4 to the negative 2x is equal to 4 to the x minus 6. And now that I have the same bases, I could go ahead and I could set these exponents equal to one another. So negative 2x is equal to x minus 6. Let's go ahead and solve that. We'll get negative 3x is equal to negative 6, and divide that by negative 3, and you will have an x value of positive 2. Whew, 2 more. Just getting tougher and tougher. But I don't want to say tougher. Getting more and more complex. Okay. So now same logic there. We're going to bring that 216 back to the top by making that exponent negative. So it's going to be a negative in parentheses x minus 3. Very important to make that entire exponent negative. Now we have 36 to the 3x minus 12. Well, 36 times 36 is going to be much more than 216, so we're going to have to change both of these. So 6 squared I know is 36. So I'll change the 36 to a 6 squared, bring everything else down over there. And now let's just check and make sure. 6 times 6 is 36. 36 times 6 is 216. So 6 to the third power is going to be 216. And I'm going to distribute this negative right now, so I'll get negative x plus 3. Almost there, where we could set our exponents equal to each other. I just want to distribute everything here now and get 6 to the negative 3x plus 9 is equal to 6 to the 6x minus 24. Now I have equivalent bases. That means I could set my exponents equal to one another and solve for the value of x. I'll do that by subtracting 6x on both sides. I'll get negative 9x plus 9 is equal to negative 24. Then I'll subtract 9 from both sides. I'll get negative 9x is equal to negative 33. And I will divide that by negative 9. And this is going to be a positive fraction, I believe. And both of them are divisible by 3, so I'm going to get 11 over 3 as my simplified fraction. So 11 over 3 is, in fact, the value of x there. Again, hesitate a little when you see that value. But when you substitute that value in for x, you'll see that they do indeed equal each other. So you didn't do anything wrong, even though you got a fraction as an answer. And our last one for this exercise is exercise for part F, where we have 4 to the 5 minus 9x is equal to, and I'm going to bring that to the top by doing 8 to the negative x minus 2. Now, 4 to the second power 16, so I can't change the 8 to a 4 to a power, so I'm going to have to change them both, and both of them are powers of 2. 2 squared gives you 4. So I'll have 2 squared, and then 5 minus 9x is equal to 2 to the third, as we saw before, and I'll distribute this to save some room. Negative x plus 2. I'm going to do some distribution. I'm going to get 2 to the 10 minus 18x is equal to 2 to the negative 3x plus 6. Now that I have the same bases, I'm going to set my exponents equal to each other one final time. And I will have 10 minus 18x is equal to negative 3x plus 6. I'm going to go ahead and I'll move my 18x over to this side now, so I'm not dealing with negative numbers. And I'll get 10 is equal to 15x plus 6. I'm going to go ahead and I'm going to subtract 6 from both sides. And I will get 15x is equal to 4. Let's go ahead and divide by 15. And when I do that, I'm going to get x is equal to 4 over 15. So again, another fraction as a solution, but that's okay because we did everything right. Yeah, 2 to the second, distribute, we get 10 minus 18x. 2 to the third, we distribute, we get negative 3x plus 6. Yeah, everything was done completely correctly, so it's perfectly okay to have a fraction as a solution. Now, if this video was helpful in doing all of this crazy work we just did in parts A through F, please give it a thumbs up, and you're now ready to continue on to exercise number 5, which is a word problem. Good luck. Thank you for watching.